Welcome to today's webinar on organic blueberry production by Dr. Bernadine Strick of Oregon State University. I'm your host, Alice Formiga of eOrganic, and we are also joined during the Q&A by Amanda Davis, who is a senior faculty research assistant at Oregon State University. So before we start, I just want to let you know that you can find all of our past webinars and many articles on organic farming and research, including blueberry production, on our website at eorganic.org and on the eOrganic YouTube channel. Today, I am very pleased to welcome Dr. Bernadine Strick, who is a professor in the Department of Horticulture at Oregon State University, and who has had a distinguished career as a world-renowned berry crop expert with over 250 published papers. She is a fellow of the American Society for Horticultural Science and also of the International Society for Horticultural Science. In 2021, she was presented with the Duke Goleta Award from the North American Blueberry Council for her high impact blueberry research. So with that, Bernadine, I'm going to give you the control now. So just click on the screen once to activate that.
All right. So hello, everyone. It's a pleasure to have you join us. I will be giving the presentation, but my senior faculty research assistant, Amanda Davis, will also be available during the questions session. And it's a pleasure to be able to highlight some of the key things that we've learned after 14 years of research that I've led in certified organic blueberry production systems. So this presentation, I've kind of divided it up. I'm going to give you a brief introduction to the organic blueberry industry here. Then I want to talk about soil amendments when establishing plantings, because that's so key, and we've learned some things that are good to do and some that are not so good to do. Then I'll move to mulching in the row, impacts on weed control, but also on soil properties, which becomes key for long-term production. And then I'll highlight our research study results on the best production systems that we found, which include planting method, mulch, fertilizer source, and rate. And I'll finish with leaf tissue testing. And then I'll summarize at the end how the industry has changed the best practices for certified organic production. So first, this region, Oregon and Washington, lead the US in the volume of total blueberry fruit that are produced, as high as 165 million pounds last year. Oregon produces more fresh fruit than Washington does. About 50% of our production here goes to fresh market. But as a region, we're known for being a global leader in the production of high quality processed fruit. And that includes for organic. We do have the highest yields in the US, some would say the world, for northern Highbush soil grown blueberries. We only have about 35% of the harvested blueberry acreage in the US, but on that acreage, we account for 62% of the total production volume. So that's a significantly higher yield than other regions on average. We also lead the world in organic production. About 20% of the 15,000 acres of blueberry here in Oregon and 20% of the 20,000 acres in Washington are certified organic. And from this acreage, we account for about 60% of US organic volume. And our industry is quite successful, as is documented by the fact that we continue to have an increase in transitional and a new organic area in this region. So the advantages we have for organic production in this region that also account for some of the highest yields in the world are we have dry summers. So this reduces the presence of weeds, which are highly increased with summer rain. So with our dry summers, we have less incidence of weeds and also canopy diseases. We also don't have a lot of the major insect pests that you'll find in other regions. Two examples would be Japanese beetle and blueberry maggot are not found in this region. We also have a temperate climate, which means we have ideal situation for good flower bud development in our long falls. We have very low risk of winter cold injuries, so we don't lose those flower buds through the winter. And On top of that, we have really good weather during bloom, and our growers typically see 90% fruit set, number of flowers that become berries. And that's a lot less in regions that get cooler weather during bloom or a lot of rain. We also are known for having tremendous industry support, and the industry levies themselves through the Oregon Blueberry Commission and the Washington Blueberry Commission. And this provides really good opportunities for grant funding, which has really benefited the research that we've done at Oregon State University. In fact, the industry approached me in the mid-2000s asking me if I could please do research on organic production systems. So let me set the stage with when the industry approached me, what did the blueberry industry look like at that time? Only 2% of the blueberry area in 2006, when I started this study, was certified organic. Those organic growers grew either on flat ground or raised beds. They most commonly used a sawdust mulch in the row for helping with weed control. Over 15 cultivars were grown, ranging in fruiting season and other traits. So the cultivar makeup didn't really differ from conventional. In conventional systems, growers were using ammonium nitrogen fertilizer sources applied in the spring to early summer, and were either applying those as a granular product or fertigated. Organic growers were most commonly using the substitution method, so that, well, if the rate of nitrogen fertilizer used in conventional is this amount, I'm going to use the same rate, but substitute an organic product. And a lot of that type of substitution method was used for other management practices. But organic growers were really tempted, and still are, to use composts as a slow release nutrient source. And that makes sense, but they were also using composts as amendments and adding them to the mulching program. And the most common fertilizer that was used was fish solubles, which was readily available. And growers would either apply that in a tank mix using a tractor with a pull behind tank, or started to fertigate. But they were very nervous about fertigating and plugging the drip irrigation systems. And they were going at relatively high rates, which was typically used also by conventional growers. So let me start here with moving to establishing blueberries and getting things right at the beginning. Now, needless to say, a good soil or site for blueberry, the soil can't have any issues with pests because of prior crops. So I'll put that aside. That's a given for both conventional and organic. But the soil needs to have very good drainage, because that really impacts root growth and, of course, the risk of disease, particularly root rot. The pH has to be suitable in acid soil, 4.5 to 5.5. That's measured in water. In some other countries, they'll give a lower range because soil is typically measured using the acid method. And so that'll be a lower suitable range. So when we say 4.5 to 5.5, that is using a water extraction method. Or, you should have a soil type where you can modify the pH prior to planting if it's higher than this. And that might be because you had a prior crop that needed a high pH. The organic matter needs to be suitable, or certainly it can be modified. So with regard to organic matter, we have mineral soils here in Oregon and Washington. There's very little peat soil, as there is in British Columbia, for example, and in the Northeast. So for us, a soil organic matter is ideally greater than 4%. And if it isn't, then we want to amend the soil prior to planting by adding an appropriate organic product. The added advantage to that is it improves the porosity of the soil and oxygen availability to the roots. Now, organic matter can also be improved in the soil after planting by the breakdown of suitable organic mulches, and I'll talk more about this. But in blueberry, the type of organic amendment is really important. because we want an amendment that doesn't injure the blueberry plants with salts when you apply it in a decent, amount to improve soil organic matter. It also needs to be an acid amendment of, proper pH, which is not easy to find in many amendments. And it should be free of weed seeds, insects, and disease, depending on where you're getting that amendment. And you can see some symptoms here. What happens when a young blueberry plant is exposed to high soil pH on the left and symptoms of salt injury on the right. So growers are faced with this, relatively long list of choices on common organic materials used, and it's very tempting to use these when they're available. If you're a grower near a dairy, for example, it's very tempting to use composted dairy manure. But you can see that a lot of these products, dairy, horse, yard debris compost, leaf debris, all have a high pH, considerably higher than what is recommended for blueberry. And many also have a high EC, or electrical conductivity, which is a measure of salt content. And for blueberry, you don't want to use a soil amendment that has an EC above 1.5 decisiemens per meter. That's too salty for use as a pre-plant amendment, and certainly in high amounts after planting. So this is an example of a grower who formed in Oregon, who formed raised beds, put a composted chicken product commonly used by many organic growers on top of the raised beds, with a goal of having that provide a slow release nutrient source and to add organic matter. And so as the weed mat you can see in the lower left was put on, and then they planted through the weed mat, they were pulling that chicken compost into the planting hole and around the plant. This led to significant salt damage on these new plants, and you can see symptoms of that on the right with a cane dying. So this illustrates the risk in using these high salt products. So we did a study looking at using a commonly recommended yard debris compost, the same that was used by organic growers at the time. We started this in 2006. We measured the composition of this compost. It was a nice compost with a low carbon to nitrogen ratio, relatively speaking, to the industry standard, which was dug fir sawdust, but it had a high pH of 7.3. And what we did was we compared incorporating a small amount. We only had a 1/2 inch to 1 inch deep layer centered on the row. We added 2-inch deep sawdust. We mixed that into the soil prior to planting. Now, the issue with this compost was that the farm that was doing the composting added lime, which is common in composting process. So this had not only, it had a high pH, but it also had quite a lime equivalent. It's like adding 1.5 ton almost of lime per acre. And we wouldn't do that with blueberries, obviously. So when we started the study before amending the soil, our soil pH in autumn 2006 was 4.9. And then in the treatment where we incorporated even a small amount of this yard debris compost, our pH increased. And in 2011, it was 6.9, above the recommended range, well above. So we started lowering the pH, just like a commercial grower would do, with 300 pounds of elemental sulfur per acre. And it has to be a slow rate so that you don't burn the plants with that sulfuric acid that's formed with rain. So we dropped the pH 1 unit a year later, but you can see we still had a ways to go. So look at the impact of this high pH soil on yield. So the graph shows total yield, cumulative, added up over that study period from the first fruiting season in 2008 through 2014, and yields in kilos per plant. We see the 10 cultivars. The black bars are no soil amendment at all, and the tan colored bars are that yard debris compost incorporated with sawdust. And notice that almost in every cultivar, the yield is significantly lower when these plants are being grown in a high pH soil. So this stresses how critical it is to keep the soil pH in the suitable range for blueberry. What is a bit misleading is that you wouldn't know this unless you see symptoms. Now, we had 10 cultivars here. The only cultivar that had symptoms of high pH was Duke. It is very sensitive, and it is quick to show symptoms of high pH, which because the plant can't take up iron, it's in a form that is insoluble. And so you see this, what growers might call, or we might call, Lyme-induced iron deficiency. So it's obvious in Duke when there's a soil pH issue, but remember there were 9 other cultivars that had lower yield due to high pH, but didn't show symptoms. So it's important to monitor soil pH and adjust it during planting life as needed. So when we look at this range of organic materials that are suited to blueberry, really, there are only a couple that are appropriate, considering pH as well as a low EC. And that's peat, which is very expensive. If you're on peat soil, that's great. But if you're not, then sawdust or wood chips or bark. Pine bark's commonly used in many regions, for example, can be incorporated into the soil and meet the needs for blueberry. So our growers in our region commonly use what's readily available, a Douglas fir sawdust. Here it's applied on the row centers about 3 inches deep, and then it's incorporated prior to planting or prior to forming raised beds. So that's organic amendments. Organic mulches can also improve soil organic matter, which I'm going to talk about now. But what are the other reasons to mulch blueberries? And then I'm going to highlight mulching options, the advantages and disadvantages of different choices. So we use mulches because weed presence in bare soil is greater in bare soil than if we use a mulch of any type. And weed control costs are expensive in conventional production, but also or especially in organic. The reason blueberries need good weed control in the row, which is where the roots are, is because they are extremely inefficient competitors with weeds. Other research studies have shown that you'll reduce weeds yield significantly when there's any weed presence, like in this young field on the left. Those plants will have reduced growth because of weeds. So stressing the importance of weed control to have maximum yield potential. The most common in-row mulch used in the 2000s was a sawdust mulch layer. It'd be applied to the soil surface, the bed, in the row soon after planting, a few inches deep, and then as that decomposes, it's replenished as needed. Now, organic growers were interested in adding a yard debris compost as a slow-release nutrient source as part of the mulching program at the time that we started the study. So we included that as a treatment. So this is a photo of our certified organic research planting. We studied the experiment I'm going to talk about now from 2006 to 2016. And the treatments that we looked at were based on industry input. So we compared raised beds or flat ground, thinking that on flat ground, if the plants did as well, we might be able to use mechanical weed control methods. And now there's research going on using electrical weed control methods and steam. So that's exciting to see the advances in weed control. We compared Duke and Liberty, which fruit at different times, but also because Duke we knew was sensitive to soil issues as well as fertilizer. The mulches that we compared were the industry standard of sawdust, a yard debris compost topped with sawdust, and a weed mat, which is a woven plastic ground cover. The fertilizer sources we compared were fish solubles, the industry standard, And we also looked at the other very commonly available fertilizer at the time, feather meal, which is a granular product. We compared a low and a high rate, which we increased from planting establishment to maturity. As the plants became mature, we kept the rate constant. And I'll talk more about that. So with regard to the compost topped with sawdust mulch, the goal was to cover that nutrient-rich compost with a sawdust layer. In the organic mulches, like the combined mulch as well as sawdust alone, we replenished these as needed, just like a commercial grower would do, generally about every few years. And during our 10-year study, we had to replace the weed mat once, so it had about a 5-year life in our study. So first, let's look at the impact of planting methods. So here you can see raised beds on the left and flat ground on the right. And we noticed there was a difference between cultivars. So there was no effect of planting method on Duke. It had the same yield, whether it be grown on flat ground or raised beds. But in Liberty, we found 22% greater cumulative yield when it was grown on raised beds compared to flat ground. And the reason for this is greater root growth. So in some of my photos, you're going to see these plastic PVC tubes with a cap on them. Well, when we removed the cap, we were able to put cameras in there and actually monitor root growth with photos, which is a wonderful tool. And so the graph on the top right documents greater root growth on raised beds than on flat ground. And that's because of greater oxygen. It's that oxygen piece that blueberry roots definitely benefit from for growing. Now let's look at mulch. So the graph shows yield from the second growing season, 2008, through the 10th growing season, 2016. We have the yard debris compost topped with sawdust. We have the dash line as sawdust, and the weed mat is a solid line with open circles. And you can kind of see, particularly towards year 10, that weed mat tended to be on the top for yield. Not huge differences in yield, but what we did find was that on average, if we average over cultivar and fertilizer, yield was 8 to 20% greater with weed mat than the other mulches, even though we controlled weeds in all the treatments. Now, again, there was a difference between cultivars. In Duke, there was no effect of mulch on cumulative yield, but in Liberty, yield was 11% higher with weed mat than the other mulches. And I'll explain why that might be as we move forward here. But one key question growers had was, they said, Bernadine, if we use this black mulch in the row, are we going to get earlier fruiting season? Is it going to have a negative effect on berry size or a positive effect on berry size? What about fruit firmness? Is it going to lower firmness because it's probably hotter? And we found no consistent effect over 10 years on fruit quality or fruiting season. That's good news. So we can focus now on the mulch effects on yield and on weed management. So with regard to weed management, look first at the photo here. We essentially had no weeds with weed mat, which is in the background. You'd get some weeds around the crown of the plant where there's that hole, but those could be hand pulled. Look at how relatively few weeds there are with the sawdust mulch compared to the yard debris compost topped with sawdust. Now, I took this photo right before we hand pulled and hoed the weeds out, so we would never let the weeds get more present than that. But we monitored the costs, the cost of labor to control weeds and the cost of product, which I'll show you some photos of. And clearly, when you look at those cumulative costs in dollars per acre, including the installation cost of the mulches, including weed mat, and replenishment 3 times for the organic materials, 1 time for weed mat, by far, weed mat was the most economical weed control method in organic production because the cost of labor and product is so high, and the weeds were more present. So while I thought I had a good idea of putting inert sawdust on top of yard debris compost so it would act just like sawdust, it didn't. The reason it didn't, as soon as a bird was digging for a worm in that compost, it would bring compost to the soil surface. Wind would blow off the sawdust. And as soon as that nutrient-rich, moister compost was on top, weed seeds would blow in and germinate quickly. The compost was free of weed seeds, but they would blow in. So it didn't work. We used different certified organic products, including a 20% acetic acid here, applying it with stainless steel sprayer. Needless to say, it's corrosive, and it would work to burn back the weeds. So did the various oil products that are available, like a D-limonene oil. But it often crippled the weeds, so it would regrow, and you need extremely hot weather for this to be effective. So in an area with high humidity and potentially summer rain, I would expect these would be even less effective. So by far, our most economical weed control method was weed mat with some sawdust in that planting hole area, particularly useful when the plants are young. And this offered nearly full weed control. We started managing the between row grass to keep it from encroaching on the weed mat using a 20% acetic acid, which we would spray using a tractor. It's expensive. So we switched to using a string trimmer pretty quickly in the trial, way cheaper. And then we'd blow off that grass debris because we don't want soil or organic material on top of the weed mat because weed seeds would germinate in that. Organic growers quickly adopted weed mat and also most commonly used string trimmers, as is shown in this commercial field. Between the row, grass is very common in our area because it goes summer dormant without the rain and drip irrigation in the row, and it prevents dust from blowing around and being on the fruit. This is a transitional field. At the time I took the photo, transitioning from conventional to organic, obviously. And this grower used propane burning to keep the grass edges maintained. It doesn't work well if there's sawdust, to be honest. It can catch fire, and it doesn't work well with weed mat. It can melt the weed mat. So it's not used very often. On flat ground, when a grower is mowing the grass, they can also use strip tillage to maintain that between row cover crop. But this doesn't work on a raised bed because you can damage the weed mat. So what other properties did the mulch have in our trial? Well, we monitored soil temperature, which is the graph at the top, 2 inches deep below the mulch layer, so 2 inches into the soil. And the black lines show the temperature of the soil under weed mat on raised beds and flat ground. And the yellow lines show the soil temperature under sawdust over several hot days. And what we found was that the weed mat increased soil temperature by about 9 degrees Fahrenheit. And it could be that Liberty prefers this slightly warmer temperature in our climate. So having some cultivar differences in sensitivity to soil temperature might certainly be possible and would be an interesting thing for further research. We also monitored how much irrigation we needed in these different treatments to maintain a soil water content that was suitable for blueberries. Based on our research, that's a soil water content of 25 to 30%. So we monitored water use, and we found that because the plants had a kind of a bigger canopy size on weed mat, we needed to irrigate more. Those plants used more water. And on raised beds, plants with a weed mat mulch use 50% more water over that study period, 2007 through 14, than they did when they were grown with sawdust or sawdust topped with compost. That's a lot more water. And on flat ground, it was 32%. And we think that's a soil temperature issue because on raised beds, the side of the bed is also more exposed to sun than flat ground. This is a disadvantage to weed mat over bare soil when you think about, water restrictions and issues you may have. The other thing we noticed was that voles or field mice love being under weed mat. They're protected from predators. And while we think that mature plants can tolerate a vole presence, remember we had the highest yield or no negative effect on yield with weed mat over bare soil, so that kind of supports that comment. In young plantings, a high presence of voles can definitely reduce plant growth because they do munch on roots. So this is a disadvantage. Moving into the soil properties of these mulches, one of the things that we did, which we encourage growers to do, is to measure, send a sample of your amendment or your mulch to the lab to determine what is the pH, what's the EC, and what's the nutrient content. So sawdust is pretty inert. It's not supplying many nutrients. It doesn't break down very quickly because it has a high carbon to nitrogen ratio. But the yard debris compost, in theory, over the length of the study, you can see it contributed a lot of nitrogen, phosphorus, potassium, and calcium. We don't know if all of that was available to the plants, specifically at a time when they needed it, but certainly in theory, we're applying a lot of nutrients when we're adding a thin layer, a half-inch deep layer of yard debris compost as part of the mulching program. So when we look at a few key soil properties, there's some things I want to point out. This shows the soil pH, the organic matter, and the potassium in the last 5 years of the study as affected by the 3 mulches. And the first thing I want to point out is notice that soil pH remained within that desirable 4.5 to 5.5 range, even though we're using that high pH compost as part of the mulching program. That's good because that means that having a mulch effect on pH did not have any, contributing factors. It was other things that led to differences in yield. The organic matter was affected by the mulch type, no surprise. Adding compost to the mulch program led to a significantly higher soil organic matter than sawdust alone, 4.1 compared to 3.3%. Weed mat had the lowest soil organic matter at 2.9%. Not surprising when you think about higher soil temperatures breaking down the organic matter that's in the soil. Also, we had an impact of mulch on soil potassium. Remember that yard debris compost is very high in potassium, and that did increase soil potassium levels to higher than sawdust alone and higher than weed mat. So that was significant. I always get questions about, well, why did weed mat have a higher soil potassium than sawdust, since neither one of those really had any? Well, weed mat's plastic. The reason for that, we suspect, is that there's less leaching of potassium from the soil when we have that weed mat over a raised bed or flat ground. Acts as kind of an umbrella. So with these changes, what did we see? We saw a response in the plant, and this shows leaf potassium, where there's an impact of these higher soil potassium levels on leaf potassium. So this graph shows leaf potassium as affected by mulch type, the bar colors there, and fertilizer source and rate. So the first thing I want to point out is that the plant response taking up potassium is directly related to those soil levels. Lowest in sawdust, intermediate in weed mat, and highest in yard debris compost. So that Increased availability in the soil is reflected in the plants. But the other thing that you should notice in this graph is that fish fertilizer led to higher leaf potassium levels than feather meal. We saw the same response in Liberty, but Liberty took up less potassium than Duke, so it had lower leaf potassium levels than Duke. So why did fertilizer source have an effect? So as a reminder, we had two rates, a low 25 to 50, so a maximum of 50 pounds per acre when the plants were mature, and a high rate 65 pounds increasing to 125 pounds of nitrogen when the plants were mature. That high rate was similar to what conventional growers were doing, to what existing organic growers were doing, and some, in all honesty, were doing considerably higher than that, applying considerably higher nitrogen. The graph shows cumulative yield per plant as affected by cultivar and the low and high rates of feather meal and fish. The orange bars are Liberty. You can see that yield is about the same, regardless of whether it's a low feather or a high fish. But in Duke, overall, it had a 35% lower yield when fish was used as a fertilizer source than with feather meal. So if you were a Liberty grower, that means you could go with a low rate of nitrogen and the cheapest product. That could save you a tremendous amount of money. In Duke, since fish was the most common fertilizer used at the time, this really raised a flag for our organic growers. So the thing to keep in mind with organic fertilizer sources, particularly those available at the time, is many contained more than just nitrogen. And that means that even if your soil has adequate potassium and phosphorus, for example, you're still applying it above and beyond to the point where it could be excess. And for example, with fish, when you're applying a high rate of fish, like we did, 120 pounds of nitrogen an acre, we were also applying 45 pounds of potassium per acre per year, even though our soil had more than enough potassium. Fish also contained more phosphorus than feather, and feather had more calcium than fish. So this led to some interesting observations. So this graph shows yield as related to plant leaf potassium concentration. So what this graph shows is then when leaf potassium levels got higher, yield was lower. So there was a negative relationship between yield and leaf potassium. The more potassium the plant took up, the lower the yield. And this occurred in almost half of the study years for Duke, but there was no obvious relationship in Liberty. So what we found in this 10-year study, and I didn't show you all the data, but I'm going to summarize it here, is that weed mat reduced weed control costs and improved yield in Liberty. The nitrogen that was added in the yard debris compost as that slow release nitrogen did not increase yield. So even though that nitrogen we know was available, and I'll tell you in a second, it was above and beyond what we were already fertilizing with, and so it didn't increase yield. Yield did not increase with fertilizer rate in either cultivar. The low rate led to the highest yield, and that's important. The yard debris compost did increase soil phosphorus, potassium, calcium, and magnesium, but it only increased leaf nitrogen, indicating the plants took it up, but it didn't increase yield, potassium, and sometimes phosphorus. Fertilizing with feather meal increased leaf and fruit calcium, which is rather significant because it's difficult to increase fruit calcium, even in conventional production. So this was quite eye-opening. Fertilizing with fish increased soil potassium and leaf potassium and leaf phosphorus. So that phosphorus in the fish was taken up by the plant. But as I pointed out, that high soil and high leaf potassium were negatively correlated with yield in Duke. And what I didn't show you is that high soil potassium reduced leaf calcium and leaf magnesium in both cultivars. So there was this competition between these cation nutrients that raised a flag. So when we look now at mulch options, considering all this, yes, these soil organic mulches we showed add soil organic matter over time. We showed they cool the soil, they conserve soil moisture, and we know they have some advantages over bare soil. But when we compare that to the plastic woven ground covers or weed mat provided the best weed control. It either led to the same yield or improved yield compared to sawdust, but there were some disadvantages that we need to address, including reduced soil organic matter, the presence of voles, and potentially needing more irrigation. So this was a 10-year study, and our commercial industry quickly jumped on using weed mat as a weed control option in conventional as well as organic production. They used a zippered system so it can be opened like this to check irrigation and to apply any needed granular products, and also leaving it open like this in the winter allows predators to get the voles, which is an added advantage. So thinking about those disadvantages to weed mat, which had been shown in other crops, I decided to try a combined mulch, which is a layer of sawdust topped with weed mat. And when we did this in the organic trial in 10 cultivars, it led to the best yield. We then did a study in conventional production where we looked at Duke in establishment, comparing weed mat alone over bare soil to a combined mulch of sawdust topped with weed mat. And our goal was to, improve soil organic matter, but also to avoid that high temperature. And we were able to do that. So this graph is from our conventional study, and the solid lines show the soil temperature under black weed mat and green weed mat, so confirming it's higher on a typically hot day. The yellow or tan line is sawdust, which cools the soil, and the combined mulch are the two dashed lines. And you can see that as soon as we added sawdust under the weed mat, basically the soil temperature was the same as with sawdust alone. And that led to improved plant growth and looked like the best option for us. So with this in mind, and with the issues that we had in adding too much potassium using potassium sources like yard compost and fertilizer, in our trial, we switched everything to weed mat. So the weed mat that was over bare soil was replaced with new weed mat, and weed mat was put over any remaining existing organic mulches that were present in those treatments. Also, we switched to a soybean protein-based fertilizer that contained only nitrogen, and we used a moderate rate of nitrogen as we moved forward. So this happened in 2017, continued to collect yield throughout the study period. So this graph shows the impact of mulch on yield per plant from the second growing season in 2008 onwards. And the vertical arrow shows when we switched to putting weed mat over top of the existing mulches and still comparing weed mat over bare soil. So you can see the dashed black line for Liberty, which is Liberty. The dashed lines are Liberty and the solid are Duke. You can see that weed mat tended to be the highest yielding, but that changed as the planting got older when it was over bare soil. You can see it ended up being the lowest yield in pretty much both cultivars as we moved on. And the weed mat placed over the organic mulches had a higher yield. So this was quite interesting and confirmed that we can get to a point where soil organic matter is too low. So once we put weed mat over top of the organic mulches, we continued to have even a bigger difference between weed mat over compost plus sawdust in 2020 had a soil organic matter of 5%, whereas weed mat alone 2.9%. So clearly soil organic matter is important for good yield in blueberry. The soil potassium, as soon as we stopped adding potassium to the program, either through compost or fertilizer, we saw soil potassium go down in our 3 mulch treatments. They were still above recommended sufficiency levels, but we can still see that because there's soil potassium in that yard debris compost, it's taking longer for that to decline. And there's still a difference between those former organic mulches in 2020. When we look at historic fertilizer use, the same thing. We can see that soil potassium declined, and we can still see a trend for higher soil potassium when we used fish, even though we stopped using it in 2017. So these things take a while to fix. But the important thing to realize is that we improved yield over this study. The other thing here is you can see a response to leaf potassium. When soil potassium went down, leaf potassium went down and then remained relatively stable. Remember, there's still plenty of potassium in the soil, and these leaf potassium levels are still within a sufficient range. Despite that, we have a little ways to go. We're still showing a negative relationship between leaf potassium and yield, with levels that are above 0.55% having the lowest yield. So when we look at the conclusions of this study, in particular the fertilizer impacts, you can see in the graph that yield increased. Even though these plants were mature in year 10, the yield increased. The percent yield increase that we saw from 2016 to 2020 depended on what type of mulch there was up through 2016 and what type of fertilizer was used. But clearly, changing to a moderate rate of nitrogen increased yield, indicating we were still not deficient in nitrogen. We had plenty. Switching to a soy protein fertilizer that had no potassium decreased soil and leaf potassium for both cultivars. Stopping compost use decreased soil potassium. All of that also increased yield. So now we've switched our leaf levels to 0.4 to 0.55%, which we found leads to the highest yield. So that's what I want to finish up with in this presentation. We encourage growers to sample leaves from lateral shoots that are below where the fruit is, or in a late season cultivar, or where fruit was produced in an early season cultivar. But questions that our growers had a while back is, should early cultivars and late fruiting cultivars be sampled at the same time, regardless of fruiting season? And also, should the leaf sufficiency standards be different for organic production than conventional? So this is a lot of information here. I know you've got a handout, but what this shows is leaf nutrient concentration from leaf tissue sampling from late April, which is about bloom for us, up until just before leaf fall. Now, this shows that leaf nutrient concentrations for nitrogen, phosphorus, potassium, magnesium, calcium, and sulfur naturally change throughout the growing season from spring to fall. Some decline over the season, like nitrogen. Some increase naturally over the season, like calcium. So what we have here is these vertical red lines show our recommended leaf sampling time for our region, late July to early August. And the reason this is our recommended time is because this is when nutrients are most stable. And that's important when you're comparing year to year. And notice that even though we have 6 different cultivars that range a lot in fruiting season, from the earliest, Duke, the blue bars, to the latest, Aurora, which the dark brown, their pattern of nutrient changes over the year are really, really similar. So we answered the question. You should sample these all at the same time, even though they have a very different fruiting season. What we learned, though, is that when we compared organic production, the green lines in leaf nutrient, this is average now over cultivar. The green line is, for example, leaf nitrogen and leaf phosphorus, the 2 top graphs. The green is organic production and the brown is conventional production. We found that even in high yielding organic production systems, leaf nitrogen and leaf phosphorus were naturally lower. And so we've used this information to modify our leaf nutrient standards. And so what you see here is the green shaded is our revised leaf nutrient standard recommendations for Western Oregon based on our long-term research in organic as well as conventional. And I'm giving you some comparisons. Western Washington and Eastern Washington recently revised theirs, and I'm giving you the Michigan standards because I know many of you in the East use those. So in your handout, you'll have those as a reference point. So what have been the changes to the organic production systems that have been informed by our research, that have become best practices for our organic growers to use to maintain the highest possible yields? Well, first of all, as I mentioned at the beginning, our growers have been very successful. We've seen a significant increase in certified organic blueberry area, with 20% total of harvested area now in Oregon and Washington being certified organic. So clearly there is economic success. Our growers need to ensure good drainage, good soil organic matter and soil pH, and prior to planting, make sure that the soil is free of pests, and that includes weed seed. So going through a fallow year is often an advantage in organic with a cover crop. Planting on raised beds has improved root growth and improves yield in some cultivars, even in our really good blueberry soil. So if you're in a heavier soil, this would be even more important. We still encourage using an organic material as a pre-plant amendment to improve soil porosity, but we recommend using a high carbon to nitrogen ratio product that has a low pH. So that would include very fine, a fine sawdust type product from most sources of wood, and a bark type product. Use yard debris or any animal compost very carefully in blueberry production because of their high pH and high salts. Most now use weed mat with drip irrigation underneath, and they fertigate. We have shown growers that with good management of fertigation, we don't have plugging of the drip lines, and with flushing regularly and using certified organic cleaning products. Our research showing we had better yield with reduced nitrogen fertilizer rates have been widely adopted, saving growers up to 60–70% of fertilizer costs, which is huge. And that's been particularly true when using fish. So I've spoken to many large organic growers in our region who reduced fertilizer input costs and had a higher yield. So they're reducing input costs and increasing returns. We now see in the industry that there are more organically approved fertilizer sources available to growers, which is very important, because if soil nutrient levels and leaf tissue levels indicate nutrients are adequate, you shouldn't apply those. It can lead to negative effects. We also have seen greater confidence in leaf tissue testing, including in organic production systems. What we haven't yet seen is a switch to a combined mulch. And the reason for that is that research is just hot off the press. So I'm guessing that as we move forward in our industry, more growers will use these combined mulches because in addition to maintaining soil organic matter and cooling the soil, I expect it will use less irrigation water compared to weed mat alone. And when field mice and voles have a choice, at least, they prefer weed mat over bare soil compared to this combined mulch. We documented much lower vole presence with this combined mulch than with weed mat alone. So Amanda and I want to thank our collaborators over the years, Dr. David Bryla with the USDA ARS and Dr. Dan Sullivan in the Crop and Soil Science Department at Oregon State University. Funding from the NIFA OREI program, the Northwest Center for Small Fruit Research, and the Oregon Blueberry Commission in particular. In-kind support from the industry has been absolutely critical to us and greatly appreciated. And needless to say, all the input and comments and advice and learning we've all done as a group, including peers and industry members. So thank you, and we look forward to addressing your questions.
Okay, thank you, Bernadine. We're now going to start our question and answer period. So if you have a question, just type it into the Q&A box and we'll be reading the questions out loud until we run out of time. So we had a really good question about the weed mat. You had mentioned a type of zippered weed mat, and if you could talk a little more about that and how that's opened up, and because somebody had a question about that second, putting the weed mat back when the plants are mature and how that's done.
Sure, that's a really good question. This was not our idea. I actually learned this from an organic grower who figured this out. It's basically having two overlapping pieces. So a grower at establishment has two choices. You can use the two overlapping pieces from the get-go using a 3-foot wide strip of weed mat and then another 3-foot wide strip that has a U-shape cut in it that will overlap with the other one. And then you use landscape staples or plastic pegs to hold the overlapping piece down. So you can start that at establishment, but needless to say, you can also use a solid piece at establishment. And then when the weed mat needs replacing, you can switch to a zippered piece. You'd have to because the plants are in the ground. The reason some growers start with a solid piece is their drip irrigation is new. They feel they don't need to check it. But most importantly, in windy areas, it's a lot more challenging to keep a weed mat in place when it's zippered and the plants are small. When you switch and replace the weed mat, it has to be zippered. I'm not aware of a source from a weed mat company that will sell you a pre-cut roll. That would be great. If anyone's online looking to make money and sell that to blueberry growers, that would be great. Or by all means, let me know if you're aware of a source. You have to cut a U-shape in so the plant fits in on the one, you overlap it and put the pins down. Growers will open it and close it. They open it once a year generally so that they can apply any needed granular fertilizers. Gypsum might be an example. Borax might be an example. Feather meal, just to switch things up. But they might also want to apply some organic matter and then check the irrigation, have the predators attack any pests that are underneath, and then they close it up again. And our organic growers typically do that once a year, and they get a crew that's quite experienced at it. And they say it takes maybe 2.5 hours an acre for each practice, opening and then closing.
Okay, is there a machine that does that at all?
No machine. Okay. It has to be done by hand, at least currently.
Okay. Also, what about solid plastic instead of weed mat?
The trouble with solid plastic is it doesn't breathe. So I anticipate you'd expect a similar response in soil temperature, but the fact that it doesn't breathe in a crop that needs a lot of oxygen exposure to the roots really concerns me. I've seen fields with solid plastic. They may not have been doing well because of other issues, but I've not seen a really productive field with solid plastic. It also has a lower lifespan, which is a huge disadvantage. The fact that rain can go through the weed mat, airflow, I think is all critical for blueberries.
Okay, yeah. Someone else wondered whether weed mat facilitates gas exchange with the
Yes,
soil. Okay,
yes.
great. Okay, and are there any concerns of loss of microbes and soil health with weed mat?
That's a really good question. And there certainly are concerns. We have documented a loss in organic matter with that increased temperature. Of course, it might be that some microbes would do better with warmer temperature than others, but in general, we would expect a loss in organic matter to have potentially some negative effects on microbes. In this planting now, we're doing a study comparing standard or organic fertilization through the drip with or without the addition of humic acids, which is a common question growers have. Does adding humic acids improve anything in mature planting? So we're testing that. And the reason I'm bringing that up is there's a postdoctoral scientist who's working with us looking at the impacts of these different treatments, this long-term management on soil microbes. I'm not aware of anyone who's done that research in blueberry. We don't have quantifiable numbers that we recommend when people send a sample in for testing for microbes. So we'll learn a lot from that. And Amanda's going to lead that project when I retire, which is at the end of this year, by the way.
So this is a very important webinar. You should take advantage of Bernadine's knowledge here. So, okay, let's see. We've got some more questions coming in. Is there a natural way to keep boron levels correct?
Is there a natural way to keep
In other words,
boron
just
levels
with
correct?
organic matter?
Not that I'm aware of. Borax, certainly with organic certification, if you can document there's a deficiency, you can apply borax and foliar, organic foliar products that are organically approved. We've had success applying foliar boron at bloom and right before a fruit set to improve boron because low boron can limit fruit set. I'm not aware of a natural way to another way to improve boron. It is affected by rainfall and obviously by soil type. We tend to have low boron in these alluvial soils that we have here, so we're fighting it all the time. Amanda, feel free to pipe in if you have any additions.
No, I was just going to say the same. We've had a lot of success using the foliar boron applications to the point where we haven't had to do it the last couple of years because we're testing for it every year and we're certified organic as well and only allowed to apply it if those levels are deficient.
Okay, great. Thank you. Let's see. Is your raised bed really a mounded bed, and how high is the mound?
The raised bed is mounded using bed shaping equipment prior to planting. It settles. I mean, we wanted it to be between 1 foot to 1.5 feet above the between row level at planting, and then tapering at the sides. So there isn't, you can't maintain a steep slope, so tapering at the sides, but that settles over time, naturally so. I think the important thing is that it maintains, that raised level with better aeration for a significant amount of the planting establishment through the early maturation years, at least.
Okay. Are the given fertilizer rates that you talked about calculated for the total area, in other words, including the alley, or only for the plant row without the alley area?
It's only for the plant row. And that is a really good question because any growers who have switched from a row crop, alfalfa, for example, corn, grass seed, to a blueberry crop, there's a difference. We are not broadcasting that 65 pounds of nitrogen per acre over the entire acre, including the between row area. We are concentrating it in the row. And the reason that makes sense when you think about it is whether you're using a granular product or you're fertigating, in both those instances, the fertilizer's only being applied to the in-row area. So it allows you to compare a granular product too. So when you see our recommendations for fertilizer rate, that is per physical acre, but you are only applying it to the in-row area, concentrating it.
Okay, great. Yeah, that was a good question. Let's see. Do you have a brand name or sources? And could you talk about the type of soy fertilizer that you use?
Amanda, I'll toss that to you.
Sure. So we've used that 2017 to 2020 study. We were using the soy-based products from Westbridge Agricultural Products, which you see the name at the bottom of the slide there. There's also a company that we're using that we used in 2021 and hopefully in the future, which is called Grower Secret. And so Westbridge sold both a liquid fertilizer that was just ready to go and ready to go into the drip. And so we used that for 1 year. And then they also had a little bit lower cost option, which was a dry water soluble product. And so that's what we ended up using for the other year. So it comes in 50-pound bags or larger, depending on what acreage you have. And then you just have to mix that up with the water. And it's a really nice product. It comes, dissolves nicely and stays in solution. And then that just gets fertigated out to the field. But those are the two companies. I'm sure there are more. Those are the two that we've worked with and that have provided donations to us also for our research projects.
Okay. So here we have Matthew, who is starting a new commercial blueberry farm, and they're going to be buying a couple thousand liners and shifting them to 1-gallon pots and waiting a couple of years until they're field ready. Our plan is to use fir bark as a potting medium. Does that sound like a plan?
We actually had a graduate student in our program advised by myself and Dr. David Bryla. He was the lead advisor, pardon me, Patrick Kingston, who compared blueberry plant growth, southern highbush and northern highbush in pine bark, 100% pine bark compared to coir or coconut fiber compared to a pumice type product. And the plants did fine. The challenge you have with 100% fir bark, just like any product that's that porous, is that the nutrients and water flush right through the pots very quickly. And the management of those pots is very difficult. So when you look at our commercial blueberry nurseries, we see them use a acid mixture that contains pine bark, but also has some perlite and some sterile type potting soil in it, which is a better option for longer term or container management. I should point out that we in our region, and probably in the US, I'm not aware of any certified organic nurseries where you can buy certified organic nursery plants. Thus, as a organic grower, you're able to buy plants from our conventional nurseries to establish a field. And that makes sense too, because of course, you don't have fruit production in those beginning years. So it does allow you, if needed, even with some other products that might not be certified organic during those transition years. So yeah, I'll just be blunt. A nursery can take better care of plants than any grower could. I grew up in the nursery business. You're set up to do that well, whereas a commercial grower getting uniform water management and fertility is more of an issue. So our organic growers typically establish using a 3.8 liter pot, like a almost 1-gallon size pot, a decent sized plant, and that's important for good establishment.
Okay, thank you. Let's see, can the string trimmer damage the weed mat?
Yes, if you don't use a string trimmer properly, it can certainly damage the weed mat. So having good supervision of a crew is really important. Getting the angle right. I mean, there's an art to it. It's a learned skill. Let's just put it that way. Amanda's good at it.
Okay. Let's see. What proportion of compost to sawdust should be added to avoid negative effects?
Do we know if that's a pre-plant question or a post-plant? Let's just say if it's a pre-plant question, I would say none. I would not use any high pH product before planting. We had a proportion of 1 to 6, 1 yard debris compost to 6 parts sawdust, and still that negative effect occurred that I showed you. That's a small proportion. And it's very difficult to work with a pre-plant amendment in any smaller proportion than that. Or post-planting, you could see that it didn't improve yield adding compost as part of the mulching program. It increased challenges with weeds, but if you had weed mat over top, you'd eliminate that problem. It adds a slow release nutrient source, but again, with the fertilizers that we used, we didn't need that slow release nutrient source. It didn't improve yield. And it could be a disadvantage for the phosphorus and potassium that most yard and animal compost contain if your soil's already sufficient. So great caution with using those products.
Okay. Does the blueberry plant's mechanism of competition between potassium and calcium work the same way as with apples, where manganese is sprayed to regulate potassium in order to increase calcium uptake by the plant?
The short answer is no. In the rosaceous crops, which include apple and raspberry, blackberry, the mechanism of potassium, calcium uptake is very different than in the Ericaceae, the blueberries, cranberry family. So the short answer is no, those same systems don't work in blueberry.
Okay. Can you speak to the different challenges and opportunities in Pacific Northwest organic blueberry production on the west versus the east side of the Cascade Mountain Range?
Not the eastern part of the U.S., but the east side of the Cascades.
That's right.
The challenges we have east of the Cascades, whether it be in the Columbia Basin of Oregon or in eastern Washington, which is where most of the organic production is that those soils are naturally of a very high pH and are highly buffered, which means that when you go to increase you add elemental sulfur prior to planting to reduce the soil pH, that works, but not for very long. And that's why the growers that, whether they be conventional or organic on the east side of the Cascades, have to irrigate with acidified water the entire growing season. That means that the roots always have an acidified, proper pH solution around them, even if you're not fertilizing at the time, like late in the season. So that has to be done. It's hotter, drier in those regions. I'm not aware of any growers in those regions that are using a combined mulch at this time. Most growers incorporate a wood type product to improve soil organic matter content and porosity prior to planting. But I'm not aware of any who use a combined mulch. Most use weed mat. And I think that would likely be an advantage in an even warmer climate in the summer, like we see in the eastern Washington or Columbia Basin, eastern Oregon. It would be really interesting to have a research study done comparing those mulches in that climate.
Okay, let's see. All right. Oh, yeah. Okay, here's someone with Japanese beetles. Would the weed mat help or hurt this situation with the grubs?
I can't answer that question because we don't have Japanese beetles. I would defer to any colleagues I have in the East who have done some mulching research. If Japanese beetle larvae go under weed mat or into the soil, pardon me, maybe similarly to root weevil, we might see an advantage, The issue you have is that any larvae that find themselves in the soil through the crown area of the plant could wreak more havoc because they're protected from predators under the weed mat. So I'm not confident in the answer to that question.
Okay, if anybody has experience with that and wants to comment in the chat box, please feel free to do that. Let's see, we had a question about the density of the weed mat in grams per, let's see, what was the...
I just answered that one.
Oh, you just answered that. Okay, well, I'll read the
Yeah,
answer then, because other people might be interested. Okay, so someone asked about the best density of the weed mat in grams per square meter, and Amanda had typed in that the black weed mat is typically 108 grams per square meter, and this product has an extended lifespan of 5 to 7 years and holds up well to tractor harvest and weed eater pressure. Would you like to add anything else, Amanda, about that?
Yeah, no, it's just it's been a good product, and it lives up to the lifespan that is advertised. So we've been definitely happy with that. And
Thanks,
as long
Amanda.
as you don't just hold the weed eater right on it and don't move,
Yes.
you're going to be okay.
Right. If I want to add something with regard to pests, the one thing we do know that weed mat is an advantage for compared to sawdust mulch is Drosophila, spotted wing Drosophila, which is a problem all through the country. When you have the heat of the weed mat, the spotted wing Drosophila love a more humid environment. And we definitely have seen lower populations in fields that are weed mat compared to those with sawdust. And that is true in the East US as well as in the West.
Okay, we have time for a couple more questions. So is there any difference in root growth spread between cultivars? In other words, does the weed mat constrain the root spread, given that the weed mat zone looks tighter than the plant canopy in mature plants?
The short answer to that is, well, there's two. Cultivars do differ in root system width. We've determined that when we've dug young plants up in other studies. So there are differences between cultivars in the width and the depth. We haven't found a cultivar that goes deeper than 1.5 feet. In general, in blueberries, the roots are always confined to the in-row area. And yes, if you still have a raised bed, that is obvious when the planting's 14, 15 years old, the roots are confined in general to that raised bed. Considering that's pretty common in our region and we have the highest yields in the US, I don't think it's having any negative effect. And so we've also seen higher yields with weed mat than without. And so I don't think that constraint is at all an issue.
Okay, great. Does the weed mat help against mummy berries?
Oh, I wish it did. Mummy berry is probably the most important disease in blueberries. I thought I had a great idea when I started this study. I was proved wrong by our exceptional pathologist, Dr. Jay Scheit. I thought that if we had weed mat, the mummies would roll to the edges. And as an organic grower at the research station, I could vacuum those up. He said, well, you could do that, Bernadine, but any that land in the crown area, you're not going to see them. And those would provide enough inoculum to continue the spread. So there is no difference between weed mat and sawdust, and there are no really great organic methods of control for mummyberry, unfortunately.
Okay, one final question here before we end. Does fish fertilizer attract varmints?
Well, I used to joke when we first started this trial that when I walked through the field and we were using the acetic acid to control weeds and we had just fertigated with fish, it smelled like fish and chips in the field when I was walking through. We have not noticed any attraction of cats or anything like that, which is kind of what I'd expect. We're in an urban-rural interface, so I expect our neighbors' cats would have come over. So I've not seen anything. And certainly with fertigation under weed mat, you wouldn't expect that.
Okay. All right. Well, we're out of time. That was a great presentation. So thank you, Bernadine, and also Amanda for helping to answer the questions. So thanks for all those great questions. And thank you, Bernadine, again, and Amanda. And thanks to everyone for joining us.
Thank you.
Thank you, everyone.